Sweet. I think we are good to go. Everything's all good. Sounds all good. Okay. All right. Hey everybody. I hope you had a nice time, little social chat before we get into week 9. Woo. Yeah. So let's go ahead and get started. Oh, also, homework is technically due right now. Hopefully most of you, or if not all of you, figured out how to use the FFmpeg writer that we talked about last week. If not, please come see us. We really want to make sure that you learn how to animate. It's like one of the coolest things you can do with Python, in my opinion. So we want to make sure that everybody does figure that out at some point. Cool. Let's go ahead and get started. So today's Tuesday. In case you didn't know that already, we got a couple of basic announcements. The instructor should be passing around a piece of paper for attendance for folks in the lecture hall right now. For those of you that are tuning in remotely or asynchronously, there's an attendance form posted on the slides. Where should I start? Homework 6 was due just now, like I just said. Yeah, animation is cool. I just want to reiterate, don't forget that your project proposals are going to be due this Friday. What day are project proposals due? Okay, good. Just want to make sure that everybody's on the same page, and they have to be LaTeX. Do not write it in Word. We will have you rewrite it. We don't want words. They have to be done in LaTeX. So that means using Overleaf, collaboratively with your project partners. We want to see a LaTeX proposal. Guidelines for the proposal are also posted on the B courses under files. I encourage you to take a look at them before you start writing, to kind of guide how you're going to write it. We talked about it quite a bit last week. Is there any questions about the proposals at this moment? Cool. If not, that's great. We're excited to see them. So we will turn them in on Friday. We'll take a look at them. We'll let you know whether or not your proposal is like feasible in the amount of time that we have with the DeCal, and whether or not we can scale up your project or scale it down a little bit depending on how you want to be. But we'll just make sure that everybody's doing something reasonable. If you said, I want to write like a partial differential equation solver that simulates magnetohydrodynamics, we would be like, no, I can't do that. No. Okay. So our last coding assignment is going to be released today. This is the last Python-based assignment. There will still be other homeworks available. So for those of you that are in the class that were looking more for the professional development side of the course, this is where it starts to happen. It'll be really fun. You're going to learn how to write a CV. You're going to learn how to make a personal website, professional website that'll make you look really outstanding relative to your peers. And we'll talk a little bit about research and whatnot, and like how coding fits into the context of that. But yeah, so this is our last coding assignment. It's going to be assigned today. It's going to cover a little bit of AstroPy, which we'll talk about on Thursday. It'll cover object-oriented programming, which we're talking about today. And it will have a little bit of pandas from a while ago that slipped through the cracks. But we want to make sure that you get a little practice with that. Yeah, so any questions before I move on to today's lecture? Okay, if not, let's go ahead and get started. So let's have a little recap, a couple minutes to talk. I know we were just talking, but it's always good to talk a little bit more. So just what is a writer? You don't have to answer that right now. I want you to talk about it with your partners next to you or your neighbors. Talk about what a writer is. How is it used? What is it like? What is it when we're animating? We use this writer, but like, what is it doing? Is it like updating a frame? Like let's just talk about what the writer is doing. We'll have the instructors kind of walk around and like kind of guide your discussions a little bit. And then if you finish that and you don't know anything about what a writer is and you want to talk about something else, what are some good strategies that you've come across for debugging your code? So when it's not working, which it usually always is not working, what do you do to fix it? There are lots of different techniques that are like valuable skills as a programmer. I can guarantee you that no like CS student comes out of Berkeley like not having a ton of bugs in their code, and like pretty much what makes them like a valuable asset to any job that involves a computer is learning how to fix your code when it's not working. Like that's really what being a computer scientist is all about, or a programmer. So being able to do that is like probably one of the most crucial skills you will gain in this decal, hopefully. So let's just discuss a couple of debugging techniques because we haven't done that really yet. So you got about 5 minutes to like chat with your neighbors, kind of brainstorm, come up with ideas. It's okay if you can't think of anything, but try your best. We'll come back in 5 minutes. And for the people on the Zoom, I'm just gonna make a breakout room for y'all. We'll just make one breakout room and y'all can go inside of it and chat. There. So it's open. I believe you have to choose yourself. So both of you just go ahead. Yeah, good. Cool. Look at me, super tech savvy. Woo-hoo. All right. We will Zoom. Do you think they're actually talking about the exercises or do you think they're just chatting? I think it's 50-50. I'm not sure. I shouldn't be putting them on blast like this. Well, I'm not. Oh, yeah, I am recording. We'll edit this out of the YouTube video. Maybe. Yep. They're vibing. I wish there's a way to like just like slam close it on them. Like, get over here. Come on. 6, 5, 4, 3, 2, 1. There they are. Welcome back, folks. Okay, cool. Sick, dude. Does anybody want to volunteer? I don't blame you if you don't. Or Claire, you want to go first?
What we discussed, and we're not sure it's like correct, but it seems like a writer is something used for like basically like tracking the state of something. So for example, like when you have a plot and you update it each time, like that gets written to like the state of it gets written to this thing, and thus like you kind of have a collection of the state of this thing at almost a multiple points in time. So that's what the writer is supposed to represent.
Yeah, it's like rewriting the plot. It's kind of like saving it. It's kind of well, it's an object, and we're going to talk about what objects are throughout this entire lecture. And you'll kind of, I think, hopefully, it'll kind of give you like a, oh damn, kind of moment. Maybe, I don't know. Maybe it's really underwhelming. But regardless, a writer is just an object in Python that allows us to kind of like write a lot of files, save them consecutively or iteratively, and allows us to stitch it together with FFmpeg. And then create a video, right? Because like we know that videos are constructed really just by looking at a lot of pictures moving really fast, like a flip book. So that's essentially what we're doing just with a code or like a writer object doing it for us. Did anybody have any good strategies for debugging that they might want to share?
I try to find code that works and is not on, and then I try to figure out what the equivalent element and does basically the same thing.
Yeah.
Figure out what the equivalent element is, and then what either I'm missing something which I would attempt to add, or I have something that doesn't look or work the same way the one that I'm using as a base looks or works, and then I will take the one that the version that they're using, try to figure out how to make it fit, because I know that the product of theirs works and mine does not.
Yeah, that's exactly. In fact, you kind of like stapled what being like a CS intern slash like anybody that works at Google does for a living. It's like learning how to use Stack Overflow really efficiently. I mean, like chances are somebody's coded up what you want to code or something very similar. So like what Nick was saying, Googling and just like finding something that's very similar to what you're doing, if not like the same thing, maybe not copying and pasting directly into your code, because I mean, that's not necessarily the best practice in the world, but learning what they're doing, trying to figure it out, and then implementing it in your own code. And that is like a really good way to debug. Does anybody else have any other ideas on how they debug?
I think it's a good strategy, but sometimes like especially if I'm running like a loop or like a lot of stuff, it's going wrong, but like I'm a little inexperienced, so I don't always know what the errors mean. Like sometimes I'll just like put like print high and like put it in different places to see like how far the code gets before it like bugs.
Yeah,
Like, it helps me locate like trial and error, like where to fix something.
exactly. Yeah, that's another really good thing to do. If you take like a CS class like CS61A, for example, and you want to kind of dive deeper into what it means to be like a computer scientist, then you can learn lots more strategies than just what we talked about. But what you said was a really good idea. Yeah, like putting print statements somewhere in your code where you think a bug might start happening, or like incrementally starting from the top and going your way down. If it runs like that print statement, then you know it's working. So that's a really good way, especially when you're debugging loops, is to like put print statements to make sure it's going on. You got any?
I will say that a good thing I've noticed to have, especially if you're something really more complex, like CS is one of the most complex that is to like just have a piece of paper nearby and either just jot down some like pseudocode or even like flowchart or diagram or something. Like it's surprisingly helpful.
Yeah, no, like that is a really good point. We don't really do that in this class because this is meant to be kind of an introductory to Python, like just learning how to use the basic tools for science. But if you really want to get into like what it means to be like a programmer, a computer scientist, then a really good strategy is to kind of like plan out your code ahead of time by like writing it down, especially when you're going into more complicated things. So let's say you have like some code that has like nested functions inside of it, and you have like a bunch of stuff going on. And you want to make sure that like it's doing what you think it should. It's really good to kind of plan out your code ahead of time, especially when there's lots and lots of lines of it. A plot statement, not so much, but you know, when you have like really complicated functions, it's a good idea to plan it out ahead of time. Got any more?
Whenever you get up to stop, comment what you think all the problems are. So you don't spend half of the next time trying to figure out what you need by the end of last.
Yeah, that's a really good point. Like saving some sort of like mental reminder as to where you left off is a really good idea too. I actually don't even do that, but I should, because there are a lot of times where I like come back to sit down. I'm like, God damn it. And then I don't remember what I'm doing for the next like 15 minutes. But yeah, that's a really, really good point. These are all really good ideas. And then also reading your error statements, like actually like sitting there and like taking the time to like read and see what it says. If you can see something like a value error, you know, like, oh, it's not the right value it should be, or it often points to like the line in your code that's wrong and it tells you where to look. So that's another. Yeah, you can also copy and paste your error statements into Google, and that might work too. A lot of CS people have done that in their life. Cool, so that's some really good tips for debugging. Hopefully, if you haven't heard those before, you try implementing them. If not, you'll learn eventually through practice. So let's go ahead and get into today's lecture. Object-oriented programming. It's a very important tool. In fact, it's kind of what makes coding, modern coding, what it is today. Throughout history, like the start of the computer era was dominated by functional programming, where you just write a function that does something. But some really, really clever people figured out that you can actually create objects in code that have their own traits and methods, and it allows them to interact in it like really well together, and you can modify your code in such a way that it makes it really nice to work with. And in fact, a lot of the code that you interact with on a daily basis is object oriented. And I think you'll see that as we go through the lecture today. So what is object-oriented programming? It's arguably one of the most powerful features of Python. It allows us to construct objects like with their own traits and their own methods. And we can create a class of objects we create objects through what's known as a class. And once you make an object, that object will have all the traits and the methods of its corresponding class. That's a lot of text and a lot of jumbling my words around. So we're gonna kind of look through some examples, and I think it'll make sense by the end of it. So here's a nice example, like a nice heuristic example, no code in sight, just kind of trying to get the idea down. So let's say I wanted to make a class of objects called humans. How do you define what a human is? Well, that could be really philosophical, but for today, we'll just start with the very basics that I can code up. So we have some traits for a human. Humans always have traits. For example, something I can think of, these are like properties of an object. So a human typically has eye color, hair color, skin color, height, weight, whatever, etc. Those are just some traits of a human. There's a lot more, but if you want the like extreme basics, those are the first things that came to my mind. And then every human has a method, like or not a method, but lots of methods. These are like things that it can do. And like a method is like a function. So it's like the object in question can do something with this method. Think of it as like an action it can take. So for example, a human can jump, it can run, clap, skip, push, talk, think, whatever. These are all things that a human object should be able to do. Now, how do you code thinking? I don't know, take AI maybe. But for our case, we can come up with a couple basic like coding rules or like functions that might mimic what it means to jump or mimic what it means to grow or talk or something. So this is just like a very basic, like heuristic example of what I mean by a class and an object. You can create an object from a human class, and a class of humans is like this kind of broad overarching model, this idea you have of what an object should be, where you could change an eye color and a hair color and a skin color of a human, but it's still a human at the end of the day. It still belongs to a human class of objects. And all these, like what brings them all together is they have similar traits and they have the same methods, the things that they can do. So they can all jump, they can all run, they can all talk or whatever that may be. Any questions about that? Cool. So now let's look at it in code. So this gets a little gross, but I think once we look through it, it won't be that bad. So just going back to the previous slide, we start with a class, human. We have to declare what a class is, or like what we're going to name our class and like what belongs to this class. So we start that by saying, defining a class by saying class human. Human is the name of the class. Class is kind of like the same thing as a def statement. It's like initializing a class that you're about to create. Don't forget your colons. And then we have something really kind of hard to understand, in my opinion, but hopefully I will illuminate your minds with it. So we have what's called like a constructor function or an initialization function. Either or, they're both like the same thing. So this is just a normal function, but with some weird quirks to it. So you notice right off the gate that there's these like two underscores at the beginning and at the end. This is just syntax. We always start a constructor function by this underscore underscore init underscore underscore. That's the name of the constructor function. It's always like that for any class you write. It has to be that name. If you don't give it that name, you're going to create a really weird class that doesn't actually do anything. You can't make objects from that class without it. Yes. So like this is essentially telling the code, all right, when I go to create a human object, how am I going to do it? What do I need to give it, like, or what do I need to make it a human? The very basics. And that's where you put all the traits. So for example, a very, very basic human only has an age and a height in my code. Of course, you can make it more complicated, but let's just say a human has an age and a height. Those are arguments in our initialization function. So when we call our initialization function, we're going to have an age and a height that we have to put into it. AKA, when you call human of a parentheses, what's going to go inside the parentheses? Well, you're going to have a number for an age and a number for a height. Now, you might be wondering, what is the self word? Well, the self is part of the syntax. So it's literally, it always has to be the first argument in your function. And what that means is, why do we have the self? It's referencing the object itself. So it's saying if I'm going to create an object myself, I need to have this self argument first in my initialization function. So it's just a part of the syntax. It goes inside your constructor function. Every initialization constructor function is going to have def underscore underscore init underscore underscore parentheses self, and then whatever follows after that. Self always has to be in your function, specifically the first argument inside of it. The actual word self. Yeah. It's like referencing itself. It's like everything belongs to my, like this object self. Cool. And then you can assign traits based off of like inputs of this function, the age and the height, right? You can assign those traits by doing self.age or self.height, self.whatever trait name you want, and you set it equal to the argument of that function. So this is where we're assigning traits. This is going back to this diagram, the eye color, the hair color, the skin color, the height, whatever. That's done with these inside of the init function, where we set self.age, self.height equal to age and height. We whenever we want to give something a trait, we use that dot syntax, dot age, dot height. Those are like variable names that we're assigning to this object. So when you reference, maybe you name a human James and you want to know its height, you do James dot age. or, you know, Isla.height. That's how you reference a specific object's age and height. These are its traits that it will belong to. We'll see more examples, and I think it'll make more sense. Then we have a method. You can have lots of methods. In fact, as many as you want. These are just functions. These are things that it can do now. So this is going back to like the functions, or like the things a human can do. What can it do? Not just what describes it, but what can it do? So we have a grow method that I wrote here. It always takes in itself, right? You can't you can write methods that don't depend on self, but then it's not really a method. It's just a function. What makes it a method is a function that belongs to an object, specifically to that object. So only a human object or a human class of objects can grow, right? You can't just say like a list can grow. This is not the same thing. We're defining this method specifically only for the human class of objects. Yeah.
Usually we define a function, you don't have to have a
Mm-hmm.
self dot something like.
So yeah, so what does the return statement actually mean? When you have a function, when you do a return of a value, it spits out that value. Meaning if I call a function like square root of x, right? It's going to return the square root of that value. And you can use that elsewhere, like assign it to a variable. But if you don't have a return statement, it might just print out what that is if it's the last line in your code, but it won't actually give you that value. It won't return it to you. You can't use it anymore. Like you could call square root of x, but it wouldn't actually give you like the value, and you can't assign it to another variable. You can't use it later. So if we don't have a return statement, it'll still do something, but it won't spit out that value. So if I call grow or like James.grow, it won't like return a number for me that I can use in a variable later, right? And the way I wrote it here, all it's doing is it's referencing its height, like itself's height was class of object, like an object to the human class's height. This is a general method, so it belongs to all human objects when we create them. But it's saying that all humans can grow, and they will grow like when we do call grow, it'll add 1 to their height. Does that make sense? Any questions about that? Okay. If not, we'll look at an example of actually creating an object from the human class. So on this slide, we wrote what the class is. This is generating, or we're creating a class of human objects, but we haven't actually made any objects from it yet. We've done the busy work. The initial work. We've created the human class, but now we need to create humans in code. So the way you do that, this line above creates an object from a human class with the required arguments of the constructor function. Oh my goodness. We're just gonna like mute it. And I think it can still pick, yeah, okay, still pick me up. So sorry about that. So this line above creates an object from the human class with the required arguments of the constructor function, and we call this object James. So just to reiterate, this is the human class, works kind of like a function, and the number 20 belongs to the age, and the number 70 belongs to the height. If we go back, we're looking at our initialization, our constructor function. We skip the self argument. You don't actually reference that when you create a new object. It's just like part of the syntax, right? So you skip over this one when you're actually creating new objects. And then we assign an age and a height. So age is 20, 70 is the height of this human object. And I just made it like whatever years or inches in my mind. And this creates like a human object, but we haven't assigned it a name. It doesn't have a name yet. So then you set this equal, or you set like the variable name James equal to this human object. And now the word James in your code represents a human object with a height and an age, and it can also grow. Okay. So now if I wanted to make James grow, you do dot grow parentheses. And this is very indicative of an object being called. And the way you know your code is object oriented is this dot syntax. James dot grow. That is a sure sign that you're working with objects in some way, shape, and form in Python. And I think you'll see some more examples of that later. Now, the parentheses is what makes it a method. I mean, the grow word was a method that we wrote. It's a function. And the parentheses is how you know it's a method. James.height is not a method. It's a trait, right? It's just a value. There's no parentheses or like empty parentheses or any, it's not being treated like a function or a method. It's just a trait. But James.grow of empty parentheses actually grows the human. Does anybody remember what the grow function actually did? Yeah, it adds 1 to what? To the height, right? So when we call James.grow, it should add 1 to James's height. So if you started with a height of 70, and then you do James.grow afterwards, if you print the height, it should be 71 now. Does that make sense? So the James.grow line is just a method belonging to the object in a human class, which just adds an inch to my height. So that's a very basic example of how we create an object. We can use its methods to do something, and it will alter the object's traits. Anybody got any questions about that? It's totally okay if you don't.
Like when we define the growth, like grow.
Yeah, so it works the same way as the init function. Self is always your first argument, but you can also add arguments afterwards. That's a good question because you will have to do that on your homework. We can take a look at that in a little bit. Oh, it's totally okay. All right. And I'll do a little coding demo in a little bit. Don't worry, there's no file or anything you have to download. Yeah.
So def and then the constructor function of def grow is a method.
Yeah. So the init is the constructor function. Always. It always comes first because you can't do anything to an object if you haven't made it first, right? So remember, init always first. Don't forget the double underscores. Those are super important.
And are there multiple types of constructor functions, or is that just
So yeah, there's only one that actually constructs an object, but there are functions that you can write that are similar in syntax with the double underscores. And all those are is like essentially rewriting operators, but we'll talk about that later when I do another example. So cool. So now I want to show you some examples of how object-oriented programming is used. Does anybody remember this? Talked about it a couple weeks ago, right? Ax.plot. What does ax represent? Can anybody tell me what that is? Yeah, like an axis object. We talked about this in the object-oriented approach to matplotlib. Now we're talking about what an object is. Ax is an actual object in the same way that we, in the same way that we created a human class and like with all these like, or like we can create objects from, you can actually create an axis object. I mean, the code is hidden from you so that it's easier to use, but that's all the syntax is going on here. Ax is an object created from like the matplotlib's class or whatever like a axis objects are, and they all have methods. Can somebody tell me the methods belonging to this class? Yep. .plot, .set y label, set x label, set title, .legend. These are all methods. Anything with a parentheses is a method that alters the axis object. Just like .grow altered the James human object. It's the same thing. We're just changing it a little bit. We're altering its traits. So the traits belonging to an axis object is like the picture, essentially. Okay? So these are all just methods to an axis object. And here's some more examples. Remember when we had like a list, you could do like .append, .remove. List is an object with traits that you can alter, and you can use methods to alter those traits. np.array, you can also, like anytime you see a dot, you're using classes, you're using objects in Python. And the way you know is this dot. Like the dot syntax is like a surefire sign that you're using object-oriented programming in some way, shape, or form. Now all the classes and stuff are made so that you don't have to, right? They're done way there. There's like hundreds of thousands of lines of code with all these different things that are pre-built for you. But when we do import NumPy or import matplotlib or whatever, we're just importing all their code, all the code that looks like this. Oh my gosh. All the code that looks like this, like tons of thousands of lines that look like lots of different traits and lots of different methods that you could possibly use. You're just importing it all. And you can use it just like this. So that's kind of cool. Like now we're kind of seeing how just important object-oriented programming is. It's kind of everywhere. It's in lists, it's in NumPy arrays, it's in matplotlib. We've kind of like everything we've been doing for the past few weeks. It's in more things. It's in data frames from pandas, PD dot something. NumPy arrays, like I said, dictionaries are considered objects. Axes in matplotlib, lists and tuples are objects. Can anybody think of anything else that we've used that has a dot syntax that might be an object? Yeah, what's up? Oh, I'm just saying that Python is like built on object-oriented programming. So like Python chooses to make lists as objects. Doesn't necessarily mean like in other languages, lists are always going to be objects. Typically they are, but Python, that's kind of one of the beauties of Python, this object-oriented programming. Another example of something that's an object is the writer from FFmpeg. That is a writer object. It has writer dot whatever. Those are different, like those are things that the writer is an object that allows us to do really powerful tools. It doesn't just have to be like these examples of things. Anytime you see a dot, just think, oh, that is a class that is an object constructed from a class inside of their code. Yeah, an AstroPi. We'll talk about that on Thursday. Yeah, for sure. So NumPy, it's kind of like, this gets a little hairy because it could be like a NumPy can be a module which has a bunch of classes inside of it, but you could just think of NumPy as a class with lots of different objects, or it's like a super class that has classes inside of it. So you can actually nest classes inside of each other too. Does that make sense? Yeah. So it's a little bit more complicated than that, but anytime you're seeing dot, just know that there is objects in there for sure. And if you want to make your own like giant packages like this, then it takes a little bit more time and research into it, and you like name the files with different module names and whatever. But the basic idea, just whenever you see a dot, think whatever before the dot is an object, and whatever's after the dot is either a method or a trait. Okay. So if you have like a NumPy array and you do like dot transpose, that is a method that you are acting on your NumPy array to transpose the vector or whatever. Okay. Any more questions about that?
So when if I import NumPy as NumPy, then do I have to put like NumPy dot?
Yeah, so that alias, right? Import whatever as whatever. Whatever comes after as is what you're going to be calling that library, right? That's the variable name we assign to it. Just like we assigned a human object to the name James, it's just assigning the variable name, but you just do it in an import statement. It's just like typical syntax. Does that make sense?
Yeah.
Cool. All right. So let's talk about a really cool example for physics. Let's say you wanted to write a physics engine, like for a video game or whatever. Physics engines are complicated. There's a lot going on. There's lots of calculations, like lots of this math, right? Anytime something moves, it's got an X and a Y and maybe even a Z if you're doing 3 dimensions. That's a lot of math. You know, when like when something moves over, you have to do like a Pythagorean theorem every time. And gross. That's why we use vectors, right? Vector notation in all your classes. If you've taken 7A or 5A, hopefully, or any math class, you've seen a vector before. Vectors are like one of the best things possible for making calculations compact notation, right? Especially if you have an XYZ vector, that's really 3 equations in one. If you have F is equal to MA, for example, F and A are vectors. That's F sub X is equal to MA sub X, and same thing with Y and Z. So being able to write everything down in vector form and calculate things in vector form is really useful. You might be wondering, how do I code up vectors in Python? You can use another package, sure. But if we want to see how it works from scratch, we can do that as well. Oh, yep. Okay, so here's an example. We have a vector class. So I apologize for the small font if you can't see that very clearly. But at the top, we say class vector. So we're naming a vector class, and we have our initialization or a constructor function with some corresponding traits. So what is a common trait of a 2D vector? It has an X and a Y component, right? So we assign those. Those are going to be parts of our constructor function, X and Y. And then we assign self.x and self.y equal to X and Y. So whenever you make a new vector, it has an X and a Y component. Then you can make it a little bit more complicated. You can add a bunch of methods. These are a ton of different methods. It might be a little like, it might look like a lot at first, but I promise it's not that bad. Anything with the double underscores for all these, like, you might be wondering, why did I name them that? It's like a trick you can do where you like rewrite what like the plus sign means in Python with these objects. Don't worry about it. It's not important. Just know that I made all these are different methods. They all have self in them. And then one of them, I also have the word other. This is like if I want to use another object of the same kind, I can reference other in my function. So let's say I want to calculate the dot product between my vector, my self vector, and another vector that's just like me. I could use self comma other, and then I can reference the other vector as like just like I would self. So self.x, other.x, etc. Yeah, so these are just a bunch of methods. And I also made it so that they return the values in case I wanted to print them or whatever. Yeah.
Like self being first and other being second matters less.
Yep. Yeah.
Can you define a function outside of like you know how everything's indented under class vector? Like, can you define something outside of the class that changes, like that modifies the object?
So typically, anytime you want to modify an object, you do it with methods. I think you could do it with just a standard function, but it would get a little messy. I would recommend just staying consistent with methods inside of a class. These are like, anytime I want to do vector dot something, I do it with these. You can write a function that takes in two vectors and like spits out like a dot product outside of this. But it won't be like, it's nice to just have it as anything, any vector class object can do that already. So it's like kind of cutting your work in half, right?
Yeah.
I guess in a way. Yeah. I think you could call it something else. We just use other for like simplicity to, it's just like common practice. Other one, other two, or something, yeah.
Which case, you want to know how many arguments you put in together. Like, you want to add anywhere from like one vector to like 5 vectors. You can do like keyword args.
Yeah.
Right? So that lets you put in like as many args as possible that just match a certain keyword.
Yeah, so like kwargs is like a good example of like, it just means like any other parameter, any other arguments you want. Like it's just kind of like a wild card. It could be like whatever, however many number. I'm gonna move on because we only have a couple minutes left. And here's a couple more examples of like different methods. Like if I want to calculate the angle between like the x and the y, if I want to calculate the norm or like the dot product between two vectors, I could do that as well. And this will be important. So make sure you look at this for your homework. This is like one of the questions on the homework, basically, is to code this up. And like a cool example of using this, let's say you had like pool balls on a pool table, like game pigeon, and you like move a ball, like every ball has a velocity and a position, right? And when you do collisions, they have like an x and a y component. So being able to do like calculate the angles or like calculate the dot products between vectors is really useful when you want to do the physics of this. In fact, this is how I wrote, or like the code that I showed you on the previous slide is the exact code I used to write a game engine or like a physics engine for a pool game that you could play on Python. What? Oh, by energy. Yeah, I mean, like this is all things you can add, like the physics, like yes, if you want to characterize like how much energy is lost, like due to like collision, right? Like or like friction or whatever. Yes, you can add those as components to your like math or whatever and your things. But this is just like an idealized case, all elastic collision, for example. Okay, I don't have time for a demo, unfortunately. So what I'll do is I'll just post what I was gonna write on code as like a PDF that you can look at and copy into your own code or like you can create. It'll be like a demo PDF or whatever, and you can just look through it, read it, and hopefully that'll be somewhat enlightening. Sorry, I didn't have time for a demo today, but I hope this was interesting and kind of like oh wow, everything in Python is objects, really. That's one of the beauties of what makes Python Python. So on Thursday, we're gonna cover AstroPy. Beloved Elon will do that. And yeah, the homework will be released tonight. There was one being passed around. Did it not come to you? Oh, yeah, can you pass it really quick before they go? All right, I'm gonna stop recording. It was really nice seeing y'all, and Ellie, I will respond to your email soon.